Okay, so this is on. I think we might as well get started. How are you today? Have you enjoyed the coffee and the breakfast and the thingies out there? How about the keynote? It was very mind opening, at least for me. I think we're kind of ready. Cool. Thank you for being here in such large number. Today we're going to talk about, well, how to deep dive or to embrace .NET in gRPC. Okay, so in .NET. So I assume all of you are like .NET developers, or you have to deal with .NET code in your work life. Okay, cool. So who am I first? My name is Irina Dominte, my married name. You'll find me as Irina Scurtu on social media. I'm from Romania. I'm an independent consultant and software architect with always a love in love with .NET. Microsoft MVP, I organize the user group, I teach .NET, and I blog, or used to. I'm not blogging as much as I would. I have, at the last numbering, I had about 100 drafts, articles, wannabe articles, but they just sit there. So, if we're going to talk about microservices or fancy, shiny, new, and useful architectures, where we might as well talk about where we first started with the monolith, right? So I must ask you, who here loves monolith or used to love monoliths? I'm guilty as charged. Yeah, and why is that? Well, because for the developer, working with a monolith was a very easy life. When you had the monolith, you had pretty much everything in your code base in one place. And if you needed something, you could have gone and instantiated that something, used that, and everything was there. And one big plus over the monoliths is that nowadays it's not valid anymore, but back in the days, 10 years ago, when you had such a big chunk of a solution and you wanted to build the thing, you might have as well build the solution and go outside, grab a coffee, stay with your colleague and so on. It was easy because the build time took that long. So one thing with the monoliths was that it's very hard to scale such thing without losing a lot of money. You had to scale the monolith, the entire thing, like put it in and create 2 instances of it. And usually, the systems have parts that are not that used anymore, or are less used than others. And that's the deal with microservices. It allows you to scale small parts of your app or your system. So it's expensive to work with monoliths nowadays. And now we have to adapt to modern architectures. So when I first started working, like 13 years ago, I started working with web forms. Does anyone here remembers ASP web forms? Yay! It was cool, isn't it? To have components that render, that respond to different events, handlers, and so on. Nice. And after that, another programmatic approach appeared, ASP MVC, and it was such a breakthrough. Like ASP MVC was the thing. Everyone wanted to work with ASP MVC. It had a clear separation of things. And then things started to move on. And the architecture started to be more split. Like you had a front-end app, and then you had a back-end, and the back-end didn't render front-end code anymore, like web forms used to do or ASP MVC used to do. So now you have 2 parts of any app to manage. You have the client app written in whatever JS, we won't mention that part, and the backend API that serves data to the client. But we all know that, well, the future is distributed, right? And to save money, we kind of need to scale only the parts of our system that are really in need of scaling. And now, the previous architecture started to become like that. We have front ends that use different backend APIs, and basically they're mixing everything together in one app. And then you have some other architectures, front end related, but not we won't talk about them right now. So every backend has one database or two databases, and then maybe one of the backends talks downstream with another backend, like a third-party APIs. You need to integrate like server to server with some other API. Or maybe your business need has something like this. Like you need, for example, to have a polyglot environment. You might have parts that are very suitable to be written in Go or maybe Node.js, and you need to consume those. Or maybe you have a .NET Core or third-party API that you do not care in what language is written. And you need to mix it all together and make it work and understand each other. And now you might say, OK, so why do we need gRPC? Because we already have JSON, and we already have the common language between everything. So we all say that we implement REST APIs. And I'm going to ask you, how many of you are really implementing REST APIs? Yeah, my hand is down. Because basically what most of us doing is HTTP APIs. We're implementing APIs that respond to JSON data to be served over the network to whatever system, right? So that REST for everything or RESTful APIs is not good anymore. It has its own applicability if you want to expose something to the public, to the outside world to be consumed. But how about downstream APIs? So API to API inside your system. And this is pretty much the thing that we're going to talk today. So now, the client-server architecture, the most easiest architecture that we know, is based on request response, where a client, being it maybe a server, a client in general, it doesn't need to be a front-end app. A client can also be an API. So when it talks to a server and gets data from a server, it does something under the hood called content negotiation. And that under the hood operation takes care of the format of the request, or you as the developer, you need to take care of these things. Like what's the format of the request? Is JSON enough? Or what are the fields that are sending towards that client? What is the payload? The client has enough data. How is that data formatted, and so on. So if a request fails, how do you handle retries? Do you implement your own thing to handle retries? How do you handle errors if something fails? How do you deal with authentication? So between two systems, authentication is to be there. So another thing that is not that easy to deal with in REST APIs is what happens if the model that you send to the consumer or the response changes. You also need to kind of force your consumer to change after you, right? Or you need to version your API in such a way that you won't break your consumers. Now, there's a different story if you own the team or you have access to the team that implements the consumer. Then you can go ahead and say, hey, team, you need to add this field or to remove this field or to change the data format of the field. But usually, some APIs that are exposed to the outside world don't know who are their consumers. They simply expose their APIs, and someone or some system will consume the API. Think about product companies. I don't know, like GitHub, right? GitHub is there. We use it every time. But pretty much there are a lot of integration with GitHub, right? So GitHub cannot go ahead and tell their clients, hey, you need to change your expectancy from me. I am adding this field, or I'm removing this field. This is deprecated. This is a process that takes time, and you can simply cannot call your consumer, hey, change yourself. I'm going to change the model I'm responding with. So this is difficult. But if you also talk, let's think about one thing. If you have two different teams inside your company that are working on separate APIs, there's still a communication between those teams. Like, I'm changing the model, you need to change what you're expecting from me, and so on. So you have pretty much no common ground and to expect and prevent errors, like with forward compatibility or backwards compatibility. So pretty much this is what is wrong with REST, besides other things that we're going to not talk about right now. So REST, exposing things over API in JSON format usually, or XML and so on. takes communication, it needs communication, needs to plan for the future, and you need to expect that your consumer will change over time and not when you want it. So, getting back to RPC. So RPC as a concept has been around since, I don't know, I think the 70s. I wasn't around that time. But RPC as a general concept will make systems behave and look like they're part of the same boundary. So RPC as a concept, I'm going to ask you to look at some code. So we have an order and a call to a create order of a specific request. C# code here, it doesn't matter what it does behind the scene, but we interrogate what's the payment process status, and regarding and looking at the status of the payment, we try to check that if it's successful, we're gonna arrange shipping for whatever that order is. The code looks pretty decent. I mean, you can tell what's happening just by looking at it. It's rather self-explanatory. And if you look at this, you might say that these are services between the same app, right, in the same context. In the monolith, maybe. These are there. So you don't care about orchestrating the microservices if these were a microservice architecture part and so on. But what if I would tell you that the process payment for a line of code, it's actually a network call. So it's a call over the wire to another API that knows how to process a payment or to respond with a payment statuses. So this does travel over the network. It takes data from one side to another. It's not in process. So RPC as a whole will make the code look local, even if the API that you're calling under the form of a method call, it's under a different system, a different server altogether. So it has a call a method look and feel. It's not create HTTP request of this kind. It's I'm going to call this method, I'm going to get the answer, and I'm going to process the answer. So because it has this call a method look and feel, it's very prone to errors. At least when you are using HTTP clients or you have HTTP client libraries, you're aware that there in that moment a network call will be made, like make a HTTP client call, get something from another API, bring it back, and process that, and use that. So with RPC, the code will look like you're just calling a method. It's not you being aware that an HTTP call will be made. So basically, RPC as a concept will make a distributed system look local and behave like a monolith, pretty much. So behaving like a monolith means that communication is made transparent. It's like you're looking through it and you're not aware that it's there. Okay, but what's the fuss with gRPC? And what's the deal with it in .NET? So a short of history, it started in 2001 as a Google project, internal one, called Stubby. And fast forwarding a few years, they open sourced it. And in 2019, we got it in .NET. Any other language out there got gRPC before .NET, and they have a gRPC version that is more stable, and they are able to use it. But with gRPC in .NET, there were struggles, and there still are. But it's more stable than it was before. So gRPC, the one that we're going to use in .NET, is contract-based. So you're basically defining a thing that you're exposing to the outside world and other systems under the form of an interface. With gRPC, you will have no more code references. So no more nugget packages that contain HTTP clients that know how to call different APIs traveling around. So no more code references that way. A thing with nugget packages is that distributing HTTP clients under this form is a way of also integrating business logic in there. And I've seen it so many times. People say, hey, I'm going to create a library for this that knows how to call the API X. And then this small library not only knows how to call API X, but has any other business logic that shouldn't be in there. So we end up with spaghetti code all over the place. Another thing with gRPC is that it uses HTTP2 under the hood, out of the box. It has a different serialization mechanism, so it's not JSON serialization. It's protobuf, which is binary, and it makes a smaller payload. That's one perk of using gRPC. It's available in many languages, which means that will allow you to basically have polyglot environments. If you have a C++, a Node.js, or whatever, you can talk through gRPC. And also, it does code generation out of the box for you. Like, you're implementing the stuff, and you also have code without you running tools or whatever to obtain the code. So if you look back at how client request response architecture will look like, we introduce something in between. So now we won't have a simple request response, an HTTP request. We will have something in between named protofile that we're going to inspect. So this protofile is simply a text-based file that has a specific syntax that describes what you're trying to expose with your services. So let's have a look. First, you need to say what is the syntax version that you want to specify, what is the namespace that you want to generate, and what is the package that you want to allow there. So what you'll do next is to say, hey, I have a thing that I want to expose and be able to consume downstream. That is called Fibo. It's a service called Fibo from Fibonacci. And then I expose an operation. And that operation is of type RPC, named compute Fibonacci. It has an input named request number, and returns a Fibonacci result. So the thing with gRPC when you're describing the service is that you cannot have like no parameters. You need to have an input. So an input being a thing that you need to pass around even if it contains nothing. It's still an input that needs to be there. So one thing in returns one thing out. So looking at the types, you have this keyword named message where you describe the input and output basically for this. So requested number is an int32 with a name number equals 1. Yeah, that equal 1 is not an assignment, it's the order of the field in the specific requested number type. And when it gets built, it's basically a C# property that you would use in a normal C# class. But in gRPC language, it's called a message. So class or message here. Same happens with Fibonacci result. You give it a name, like a property name. And if you would have more properties, you would go below, write in property name, and then equal to see that is the second in the order in there. So I might ask you, this sounds familiar. Have you ever worked with WCF or SOAP services like that? Yeah, there. You see how funny it is in IT, in software development, there are some concepts that tend to die, and then after a few years resurface under a different form. So this is one of those forms. So one of the cool things about gRPC is that it supports something that is called types or modes. It's unary, like request response the easiest way, as we all know from client server request response, server streaming, client streaming, and the combination of the previous two. And if we were to look at the animation, how you describe this, is you have a client, you have a server, as you have in any other architecture. So two entities like talking with each other. The client initiates a request, a HTTP request, and then the server receives the request and sends a response back. So one thing in, one thing out in the unary type. How would you describe such thing in a service? It's simply as you've seen before, input type returns output type, and that's it. The next one, called server streaming, it's similar. The client still needs to initiate a request, so it's not like server going, hey, you, do something. The client still needs to open a communication line with the server. But now, if the server streams, it means that it sends several pieces of data under the same TCP connection. So one thing in, several things out. And you depict this just by adding the stream keyword near the part that you want to be it as a stream. So in this case, I have one thing in, requested number, and returns a stream of Fibonacci result. So many things out. The next one, client streaming, it's pretty much similar, but the other way around. The client still needs to open a communication line. It sends several pieces of data. The server receives the data and sends back one thing, like one response. Think about this, how would work, for example, upload things. You chunk the thing and upload the bytes and so on. Or maybe collect data from different sensors. Like if you have 100 sensors, every one of those will open one communication line, so one connection, and send several pieces of data in. Instead of having 100 sensors opening a new connection every time they want to send data. So this is HTTP 2 under the hood, and this is why it's possible. So 100 and many things in versus 100 or multiplied by whatever many things you want to send to the server. So how you write this, that you're going to expose just by adding the stream keyword near the part that you want to be as a stream. So in our case, several stream in and one thing out. And the last one is the same, but it has several things in, several things out. So combine the two of them, and you'll have bi-directional streaming. So a quick note, this happens over a single TCP connection. So one line of communication and many things traveling back and forth. How do you write this? So by adding the stream keyword, a stream of things in and a stream of things out. Cool. Let's see some code. And I'm going to show you how you create such a, I hope it's visible enough. I'm going to try to zoom it. So basically in Visual Studio, you have the project template that it comes, and you click next, you give it whatever name you want, and it will end up creating a solution file for you. I just want to show you how the project structure looks, because it will look the same in my demos. So I think you all worked with the Web API, or you had, or MVC, where you had the controllers folder very well organized. Well, in gRPC, you have no controllers, but you have Protos folder, and you have a services folder, and the rest of the things, they're familiar. App settings, where you can read and configure things, program CS, and so on. By looking at program CS, I hope this is visible further down. Okay, how do you basically activate a gRPC thingy? So you just add the middleware, add gRPC, and then you need to say, hey, I'm going to map a gRPC service called this way. So this is part of the template. It gets generated, but I'm going to show you how it gets generated. So looking at the proto file, we'll see here that it's a service that exposes an RPC method called say hello. And it has two types, the input type and the output type, hello request, hello reply. And basically, what you need to do is to give an implementation for this. It's like an interface. You have the proto file that specifies what you want from your server, but it's still your job to implement the actual content. So you have greeter service. Okay, so greeter service, it's a class that will inherit this. Greeter base. This is the code that is generated for you. So it's part of the template and the code generation that is there. This is the base class that is generated in order for you to override what's inside. For example, I'm going to F12 in here to show you some funky code. You see that this is abstract partial class greeter base that has pretty much what I need. So it looks at the proto file and will generate a stub. What's here? Say hello. So you're basically overriding this method that is generated for you. So in the service, you just go ahead, override the method, give it that, hey, I get one thing in, I'm going to have to return this out, like the message type. Okay, one thing with gRPC service implementations is that if you specified, hey, I have one input, when you override the method, you also have this second parameter or third or fourth parameter called server call context, which is similar to what we already know from HTTP clients, like the context of the current request. Well, this is the context of the gRPC request. So if you have a client streaming, you can access things related to this piece of information by using the server call context. And on top of it, you have the HTTP context that you all know. Cool. What we have in terms of packages is gRPC ASP.NET Core and a specific version. This is what you need to add. And pretty much you have a server implementation. And another thing that you can do with any other, for example, I have, and I'm going to show you console apps. You can edit the project file, and you're going to say, hey, you will find a proto file under this path, and this path is not necessarily to be under the same project. It can be on a network, it can be on disk somewhere, but you need to make sure that the proto file will be accessible by all the apps that need to consume it. And also another thing that you need to add in here is that, hey, this specific project is of type gRPC server. So you add this parameter in here with the value to depict that is a server that will serve a gRPC request. So enough with this. Let's have a quick look at my demos in here. So what I have a server that has the 4 methods implemented. And then I'm going to have 4 console apps, unary, bi-directional, client streaming, and server streaming, that are nothing more than console apps doing requests to the server. So in this specific case, you will have to have a server running and the client that makes requests to that server to get responses back. So let's see how the server looks. Proto file, I'm specifying the 4 methods. So it's still called a greeter. I am exposing a say hello, one thing in, one thing out. And for any other method, I have a stream of request in, returns one thing, and so on. The name of the method, it's rather, I try to be very intuitive. And what I have in here is what I sent, so a request with a property called content value, and the response with the property named message. Okay? So this is the proto file. And then for one consumer, I'm going to show you that I have no code references. So I have here, and I'm going to show you why I have that many packages. So packages, I'm not seeing a reference to the server. So no, the only thing that I need to add in common with this project is in the CS project itself, I have this protobuf include to make it reach the proto file that lives on the server project. So you might as well have it in any other place on top of your specific .NET project. And in this case, I'm specifying that is a client instead of a server as I used before. OK, so I'm going to close all this. And I'm going to get back to the server, to show you how things will go. So say hello. It's an overrides the base class. It has one thing in. It has the several contexts that you can access. And it basically sends back what you send in with some extra strings. Like I'm going to say hello back with what I send, value from the host server. And I'm going to show you one thing before I dig more into the code. So I have a console to the left-hand side that I'm going to run. And here the server instance will just listen for incoming requests. So it will listen on this port 5000. So server running, up and running. And then on the right-hand side, I will also have a console with that console application running, the console app. So what I will do is to run this, and if everything works fine, I should see things moving. So what I'm sending from the client part, I'm sending NDC, and I get a hello back with NDC value from this particular server. So I added this just because I wanted to show you some more things in the end. So let's have a look at the server side to see what happened. And I hope it's big enough. So on the server side, some things happened. A request came in, and then the request came in for localhost 5000, greeter, say hello, with a type of application gRPC. So it's not application JSON or whatever we used to do. It's application gRPC. It has a 200 as status code, but that status code is at the TCP connection level, so HTTP communication channel. It took that amount of type, and it's of HTTP2, and another thing, it's a post request. So everything that goes to a gRPC method call, it's post. So no matter if you're getting data, you do a post. Just as we used to do way back where we didn't use like HTTP methods. So getting things, post. You're sending things, post. Yeah, so every other request it's a post request. Cool. So classical client-server request response. And if we were to look at the code in the client, there are a few things that we need to talk about. For example, so gRPC talks in channels and clients. So in order to make a request toward gRPC server, you need to open a channel. You need to specify which is the address. And then you can specify some channel options, like credential, if there's the case. But in our case, we're going to do insecure calls because we like it that way. And then we're going to use the client. And you'll see that you have greeter client. And this is not code that I've written. This is auto-generated for you when it discovers the proto file. So greeter client, you pass the channel, so the communication channel to that port. And that's it. You create a request message. As I told you, you cannot issue requests that have no values. So you need to use those messages that you described in the service. And then you simply just do client, call the method that you want, and that's it. So in our case, we have say hello, client stream, server stream, bi-directional, and so on, already implemented on the server. So this will be visible in your client. OK, so you've seen this working. And some other things that you can pass around is that you can do some options for every gRPC request. So it opens a communication channel, and inside it, a lot of things related to gRPC will travel. And sometimes you need to access those things. So you can also pass some other things, like you need to pass metadata in it. I'm going to uncover, but I'm going to get back to it like later. I'm not writing code because I don't want you to see me like how I type badly. So you can pass headers, but these headers are per gRPC request, not at the HTTP request level. You can pass it a deadline. For example, if you say, hey, if you do not get back from the server in that allotted time, consider yourself dead. That's the timeline that you have to get back a response. If you don't, then, well, throw an exception. And also, you can pass cancellation tokens if you need. So let's see. The server is still running, listening. And from the Unary console, I'm going to run it again. And if things go well, we're going to see an exception, which was intended. I'm going to make this more readable. So we get an unhandle exception, an RPC exception with status code deadline exceeded, so on and so forth. So this is what we wanted to obtain. So, well, 1 millisecond, it's super small amount of time. So we got this. Cool. The second one, server still listening for incoming requests. We're going to see how client streaming works. So I'm going to .NET, run it. And you'll see on the server that things are getting in. A lot of things are moving. You see I got a request with whatever content value and so on, so a lot of things. And the client got one single response. So this value is the last value received from the server, which is corresponding to this. The actual implementation for it is on the service here. So it's client streaming. It's basically a loop, that goes, it awaits requests, right? And it simply writes the request that it gets from the payload. Okay, so you're looking at the request stream. When you override this, you'll get a request stream. That's why the stream keyword in there and the server call context. And you will be able to access the request stream and extract key from things from there. For example, when you still have things, move next and access the current thingy that it's traveling through there. So in the client stream, this time, in the console app, the scenario is pretty much the same for every other example that I did, as a for loop going to this value and just sending requests towards the server. So it loops and creates a new request and then waits for the last response there. And you see here, canceled, you can catch exceptions, but you need to filter those exceptions over a status code. And that status code, it's different than what we used to use with HTTP. There is still an OK, but that's not HTTP OK result. It's related to the specific gRPC inside. For example, out of range, invalid argument, deadline exceeded in our case, data lost, canceled, and so on and so forth. So status code for the specific gRPC one. So client streaming, we watch this. Let's see the server streaming. So you see the information in there, still running. I'm going to run this. Server is streaming back things from the server side. So several things out, one thing in. Okay? And you're going to see some things in there, like found some trailer values in gRPC header that I'm going to show you. So basically, in server streaming, you have a way of sending several options in the request. You see, so I'm waiting for each response in the response stream. I'm reading all the response stream. And I can search for a key, for a value, for a key, sorry. Get value, my fake header, and you can write that back. Cool, and bi-directional, and then I have some more example to show you. Server still running, and guess what? It's gonna send 10 things in, and it's gonna get 10 things out. But don't get fooled. This ordering is not guaranteed, like on how HTTP is working. So I was lucky this time. So I'm sending the eyes, and I'm receiving the eyes back again. Okay, and bi-directional, it's a combination of the two. So you're calling the method that you're exposing to the proto file, and you wait for everything to come in, and then you wait for the things to come out. Cool. Let's show you some more things. We talked about trailer values. And I said I'm going to show you how you can extract things from the context. So you have the server call context, where you can get the HTTP context of the specific gRPC request. And you can get things like what's the user for the current. You can get the claims, or maybe you can get the client certificate that is passed for that connection. And you'll be able to do this inside every other gRPC method that you're exposing. Another thing is that you can mimic headers per gRPC request, in terms of they allow you to send headers back to the client, not at the HTTP level, but at the gRPC one. So how you do that, you simply just add to that context response trailer, and you add a key with a value. and that will be traveling towards your client. And just add it to the response, just as you would do with a traditional header in HTTP, but this is down beneath. Okay, let's see what else I was supposed to show you right now. Okay, moving back to the slides, because I have some more things. Talking about gRPC internals. So until now, we talked about, okay, how things are working, what you can do, and so on. But internally, gRPC status codes are different than HTTP status codes. As I told you, you have, when you catch an exception, for example, you need to filter out by what happened. So this is inside the communication channel. So these are different. Another thing that you can use with your gRPC request is RPC exception. Guess what? With gRPC, you have one exception type. It's like exception, the God class. So in here, you have RPC exception if you want to deal with RPC. Well, basically, what's inside, it's up to you to discover. So RPC exception, looking at the code, server side. Oh, sorry. You can catch exceptions, and you can treat them like differently when the status code of that specific exception it's on a specific range. And you can also use this for retries, and we're going to talk about that soon enough. Okay, so catch RPC exception, catch again an RPC exception if what specific status code happened, and you can treat them this way. Okay, request headers. So when you issue a call, you can add a request header. When you issue a response header, again, you can add those trailers to the context, and it will be visible on the client. And the same happens with response, trailer, and so on. But one thing is that you still have access to what you had before. HTTP context, the top level, you can add there, things that are visible in the HTTP call. So if you're thinking about implementing this, you can also tweak some things, and you should tweak some things. For example, you can enable detailed errors just by putting this on true. You can configure the maximum size of the request. If you have scenarios where, I don't know, you upload things and you want to limit each chunk of data that goes to the server, then you can add this, configure it as an option, I don't know, 2 megabytes or more or less, depending on the scenario. You can set what is the maximum of the message size, again, depending on some computation you might need to implement, to think about, sorry. So another thing that is a good practice, even in APIs or in things like ASP MVC, is regarding the compression level of the response. So you can add different compression types in here, and you can say that, hey, I want the compression level to be optimal, and it will work things for you. Or maybe I want to use a compression algorithm that is gzip or whatever, and you can add that in here. Or maybe you want to implement your own compression provider or add your broadly compression, or why not, your own. You can add this in here. Another thing that is worth mentioning, it's called interceptor, and it's a similar thing to what a middleware is, right? But this time, the interceptor intercepts different types of gRPC requests. So if you're talking unary, and that it's a blocking call, you can create an interceptor and you override that. Also, interceptors are of two types on the server side. You can add that, like I added in here. It's generic, you can create your own. Or you can intercept things when you send the request towards the server. So you basically, you'll be able to create something that is like a, I don't know, a pipeline, just to add more things in the gRPC request, like you would do like with a normal middleware. Let's see such an interceptor. So for example, in the client side, I created an error handler interceptor, but I did not get through it. So interceptor, you inherit this class, and you override what you need. For example, I need to intercept when things are like calling gRPC unary, like blocking, async. You have some weird things like there, the context and the continuation. Again, it will wait for the next interceptor if there is one. Just like it happens with the middleware, you pass the control back, and then control gets back to you. And, well, you can add things in here. Another thing that you can add is interceptor at the server level. For example, you can implement a logging interceptor, I don't know, to not necessarily to log, but even to trace things related to gRPC requests. You can pass parameters if there's the case. You can inject things. And for example, I need to pass the unary server handler, server call context, and to log things like, hey, I'm starting to receive a call of this type. You see you're awaiting the continuation for the content request, and so on. And if you want to activate this, you simply need to go into the gRPC part and just add it in the server part. So if we're looking back here, supposedly, let's see, unary, started. I'm going to maximize this a bit. I'm going to .NET run it to see how it works. OK, yeah, of course, this died. I'm going to comment this thing again. Seems to be working. Building unary. I'm going to clear the screen just to. I'm not seeing it. OK, here it is. I wasn't inspired enough to create it. So it's an info message like logging information. It's in server logging interceptor. I'm starting to receive a call of type unary in method greeter say hello. So I'm intercepting only that specific type of calls. And it's up to me what I do with them. So either I'm extracting claims, you can use that. You can extract claims, you can extract security-related things, or you can log or whatever the business case you have, you can intercept each one. So moving forward, if you talk about security, since I just mentioned it, you can basically use everything that you use in a web API. And now you have two options. You can put it at the channel level, so for each gRPC thingy that travels through the TCP channel, or at the connection level. So TCP connection, whatever you would use there, you're able to extract information and to be able to see if the call is allowed or not. So Azure AD client certificate, JVT token I should remove from there, OAuth, WS Federation, and so on. So there are different topics to talk about security, and I'm not going to dig into it right now. But I have a few more things that I want to show you. Since .NET 6, gRPC should do some awesome things in .NET. And one of them is called gRPC transcoding. Some people say, hey, I won't use gRPC to my downstream APIs. I'm going to keep using HTTP calls, because my APIs are also, I also need them to be exposed like to the outside world in the browser. And I cannot use gRPC for that without using a gRPC web or some other tools. So guess what? There is this thingy called gRPC transcoding that allows you to do exactly that. So allows you to do, I have a server that's called transcoding API that listens to a specific port. And I'm going to show you this. Sorry. Transcoding. Basically, right now, it's a hack, but until they release .NET 7, I hope this will be fixed. You need to copy from GitHub some folder structure called Google API with these two proto files. And this basically will allow you to, you also need to import them in your proto file. And this will allow you to do this. to say, hey, I need to have an option to expose this as an endpoint in the browser, as in process, but to also be in the browser. So in our case, I want to expose a GET request under this path. The parameters will be bound from the path, and we'll be able to do this. So HTTPS, localhost, the port that is running, v1, greeter, and name. And we're going to get back hello, the parameter that we're sending. So if I'm sending NDC, I'm going to get back hello NDC. And this is very cool because basically what I have is the gRPC servers. Here it is. Complete implementation, and I have the option of, hey, this is gRPC to my downstream, but I also need to expose this in the browser. It's still new, fairly new, and not stable enough, but it also works with post requests. And it also allows you to issue requests, for example, from the browser. So I'm sending a name in. So in Postman, in beta version, you're able to send messages with gRPC. And if we invoke this, we're going to get back messages from Postman. So I think this is very cool, because you couldn't do this before. And now you basically have two rabbits, one stone, and you'll be able to touch them both. So gRPC transcoding is one of the things that is very cool. Another thing is transit fold handling. So if you ever used Poly, now you'll be able to use this also out of the box without using some extra packages. So here. You'll be able to configure either a retry policy or a hedging policy for each request, because this will be passed through the channel, so specific to the gRPC piece. So basically, you can say, hey, what are the max attempts to retry, the initial backoff with a time span, maximum backoff multiplier, and which are the retriable statuses that you want to do. So basically, you won't. Sometimes you don't need to retry every time, just when something happens, and the status code that is there triggers. The hedging policy, again, you can specify hedging delay, maximum attempts, and which are the known fatal status codes that you want to use again. So you can specify the method config, give it a name that is comfortable for you, and then just pass it to that client. Okay, I'm not going to demo this, but another thing that I'm going to demo is client-side load balancing. What if you could do client-side load balancing without using some additional tools? And now you'll be able to do this. What you have to do is to allow this to have and to be either a static resolver factory, or you know the DNS, and you can add the resolver factory. So basically, what we're going to do is, hey, I need to I know the addresses that I will have a server running, this port and this port. So every time you want to create and issue a gRPC request, you'll be either be served by one of them or the other one, based on the policy that I'm specifying. Okay, so I'm going to specify, hey, for this address, give it a name, localhost. I have these options for the channel, the credentials, and I have the service config, where I'm specifying I want it to be round robin. So take one and the next one and so on. And for example, if you want to say, is the pick first also? Or you can also implement your own. So what I'm going to do, okay, so we're issuing requests. I'm going to have the server running. It's still running. And I'm going to have the second server running on port 2002. So 2 instances of the server. And now I will have another console app that will be running and issue requests. And we're going to see, hey, we got hello back with NDC value from localhost 5000. And now if I do the same request I said, just a sec. This is running. I'm running what I need to run. don't know. This should work. What happened? Okay. Demo gods today. Anyways, I'm going to try one more time. Extras gRPC. Clear screen. Balance, DNS, build server, console, say hello. Transcoding, transcoding, transcoding. No, not this. I'm gonna close it. Live demos, right? So this runs. Okay, I'm gonna give up. I don't know what happened. Yeah, but basically client-side load balancing, not in my case apparently, but it should serve you like the first one and the second one before. Okay, let's see what else do we have. Client-side load balancing. So DNS resolver, static resolver, pick first or round-robin policy, and if you want, you can implement your own, like take the first one, and after next 5 requests to the second server, and so on. Sky is the limit in here. So I'm still wondering why that demo doesn't work. So what are the benefits of using gRPC? First of all, I think it's visible and important enough to look at the performance versus size. So the same request, the same response size for an HTTP API versus a gRPC gives you a payload that is 80% smaller in the payload response, just because it's different serialization. Will allow you polyglot environment, which is important to have a system that is pretty much serving everything from the language that it's suitable enough. Low network usage, point-to-point, because that's what you expect, point A to point B. Make data traveling over. So HTTP, multiple calls over TCP connection is very important. It's contract-based. HTTP2 supports different streaming types. And it can be configured to run with HTTP3. I don't know about you guys and girls, but I'm personally just getting my head around HTTP2, and now they're talking about HTTP3. It's hard to keep up sometimes. And as downsides, it still has the temporal coupling. So the temporal coupling will be a thing that will allow you to not to lose anything just by using service buses, messaging, and so on. And gRPC is not the technology for that. It's not humor readable. It wasn't humor readable until Postman created a better version of it, and it addresses gRPC. You'll need better testing, and you'll need to focus on CI/CD. In a way that will prevent you from losing access to the proto files. So if you're traveling a file over the network, you're going to make sure that you test that thoroughly. It does only post requests, which means there's no caching for you. Yay, right? No. I think they will work on solving this also. You have the single point of truth, the proto file, so no one-code references and so on. And it's not supported in Azure. It is supported in Azure. After 2 years, they brought support in Azure. So when and why gRPC? So when you have downstream APIs in your system that you also want to expose to the outside world, it has 4 ways, it's performant and so on. And, distributed systems are all about trade-offs. So we need to pick the right technology for the specific job that we have. And we should know the tools. So as next steps, because my time is up, is to look up these, gRPC web, HTTP3, and stuff like that. And you'll have the resources in here. So demo and so on. Also, thanks for listening. And don't forget about the scoring, the cards, no reds, only greens on your way out. So thank you for listening to me.